Welcome everybody. I would like to talk about one lecture in the advanced topics class, empirical exercises in international economics. So, what is the topic all about? The topic is about the Ballassa-Samuelson theorem, and according to this theorem, it is the case that countries which have a relatively low real GDP per capita they have a relatively low price level, and more advanced economies like industrialized countries, they have higher price levels. For example, when you are doing a haircut in Switzerland or in Norway, that's very costly. Prices are relatively high. And when you are doing a haircut in a developing country, prices are relatively low. Like especially the prices of non-tradable goods, for example, a haircut, they are very low in a developing country. And this is what we are going to test in this lecture because I received a data set from a YouTuber, like he's riding his bicycle throughout the world, and he recorded like for about 600 days how much he spent every day. So, like we have a data set on the daily consumption. Furthermore, we have information of which kind of country he has been. So he has visited a lot of different countries, and he started like in Germany, Austria, and Switzerland, and then he went like to other countries on the Balkan. Sometimes he did not camp on a camping site, so this is called like wild camping, where he did not have to pay anything. Sometimes he has been on a camping site, like the yellow part of the cake, then a hotel room, which is like the red part, and then sometimes he got invited from some people, or he was sleeping at some friends, and this is only a small proportion of all days. In his video, he talks about that there is a kind of time trend with respect to his expenditures. So in the beginning, he spent a lot, and in the end, he didn't spend so much. He says that this is due to the fact that he learned over time how to save money. So maybe we should also include like a time trend in our regression. It could be also the case that first he visited like countries which have a relatively high real GDP per capita, so Switzerland, Austria, and Germany, and then he visited some other like developing countries. So I don't know whether he's right with his perception that he learned over time how to save money, or whether it's due to the fact that the visited countries have different characteristics over time. But this is what we are going to examine here in this lecture. So our hypotheses are as follows. Like when he is using like a hotel room, this is the most expensive like day. Expenses depend on the country he is visiting, so the GDP per capita of the country is important. And then another hypothesis is that the expenses decrease over time. So these are our regression equations. In a first step, equation number 1, I have the daily expenditures on the left-hand side, regressed on a constant, and then a dummy variable, whether the person used a camping site, whether the person used a hotel room, whether the person used a private home of a friend, and then we have the time trend here. Epsilon is an error term. In the next step, like I tried to include country dummies from Albania and so on, like all the way to the UK. So I tried to include like 20 country dummies, but I failed. This was not possible like in Excel. Then third equation, I want to include the Ballassa-Samuelson variable. So I want to include GDP per capita measured in thousands of US dollar. In the end, I would like to run a regression in logs. So I'm taking the natural log of the expenditure. This will be my variable on the left-hand side. And I also take the natural log of GDP in thousands US dollar. And this will be inserted in this part of the regression. So the blue stuff, they are related to where did the person sleep, camping site, hotel, or private room. Then we have a time trend, and like the green stuff, this is related to the Ballassa Samuelson theorem. So like these variables here, they are country specific. I would like to run like the following pairs of hypotheses. So I would like to perform a hypothesis test. So it's important to write down the hypotheses. The null hypothesis is always that the coefficient is equal to 0, and the alternative hypothesis is that the coefficient is unequal to 0. So we always want to perform like a two-sided test. And in my course, we always test on a 95% confidence level and assume that we have enough observations so that the normal distribution is the appropriate choice. And therefore, in my course, like the critical t-value is always equal to 2, or in case that you want to be precise, it's 1.96. So these are already regression results, but let's switch to Excel and let's have a look at the data set. So here we have one overview, like this is performed by the YouTuber. So here we have the information about the different countries the YouTuber visited. And here we have information on where he slept. Then we have information about all the expenditures. So here, this is daily expenditure, and we have information about whether he was sleeping on a wild in the woods, like wild camping. That's green. It's a 1. A camping site is a 2. Like a private room, red. That's a hotel room, like a Zimmer, like a hotel room. And blue, there are only a few blue nights here, like sleeping at a friend's place in a private apartment. This is more or less the information we will use in the end. But it's also the case that there are some more information in this data set. So he also has some extra columns when he made like some purchases related to the camera, like he bought a new video camera, or like he bought something else. This is not interesting for us because it's unrelated to our question. In the end, he also has some information about his income. So some people are supporting this YouTuber, so receives a grant via PayPal. But he also calculated in the end the amount of time he spent. And in the end, it is a case that he has an hourly wage of about 4 euros, which is not very high. But this is completely unrelated to our question. So I have here our data set, which we are using. I had to exclude 3 observations because sometimes the information with respect to the country was missing, and 2 times it was the case that I did not know where he slept. So like I had to modify the data set a little bit. In column number C, we have the expenditure. So on the first day, he spent like 22 euros, then 44 euros, 48 euros, and day number 4, that was very costly, like 132 euros on this day because he took a hotel room in Switzerland. Okay, in a first step, like I can augment it a little bit so that you can see better like my data set. Like here, I would like to create a dummy variable. and I would like to use like the if function here, and this works as follows. So I'm using the if function. Sorry, I'm messing up. So the if function, and I say if this one, and I'm freezing column number D, and I'm only freezing column number D by putting a $sign in front of D. If this one is equal to this cell, then the dummy variable should take a value of 1, because this was like a wild camping day, and else it should be like a 0. Furthermore, I want to put like a $sign in front of the 3, because I want to freeze row number 3 when I copy this information all the way down. So like a $sign in front of D and a $sign in front of row number 3. So now I can create like the first dummy variable. So when I copy this information to the right, it should be the case that the other variables like camping, hotel, and private should receive a 0 now, because this guy was like wild camping on the first day. When I copy this information down, like the 1 should be here, because of the fact that this guy was using a camping site. Next day also camping site, so a 1 here. And when I copy the information further down, like the very expensive hotel room should have like a 1 here in this cell. Let's check. Great, the function works, so it can copy all the information down. Here I have a cross check. It is the case that about 50% of the time wild camping takes place, which is the case. We have 618 days in our data set, and about 50% that's wild camping. Only on 18 nights the guy was invited to sleep in a private house or apartment where he didn't have to pay. So this is the blue part, where like he only spent like a few nights in like a private apartment, a private house. Let's go back. Next thing I would like to include is a time trend. So like here we have the information with respect to the overnight stays, and now I include a time trend. So I'm putting a 1 here, a 2 there, like a 3 there. And then when I copy all the information down, like the last number should be day number 618. So that's our time trend here. Let's check last number. Yes, it's 618 in the end of our data set. Now we are running a regression. We are only including like these explanatory variables. We are omitting wild camping. This is like important. We are only using like 4 explanatory variables. We are omitting wild camping. This is the y variable, and these are our 4 x variables. So I go to data, data analysis, and then like I'm checking for the regression tool. Regression is here. Input y range. This goes from cell number C4 like all the way down to C622. So I'm also including the information in row number 4, like I'm including the labels. Also here, I'm starting in row number 4, and then I'm going all the way down, and the input X range, this is the area from G4 to J622. I'm making a check here at labels because we included the labels in row number 4. So it's important to make a check here at labels. Then I press the OK button. This is my output. So I start to format the output a little bit. So this is fine. Then I'm checking whether a t value is larger or smaller than 2. Whether the coefficient is significant, yes or no. Like I don't need this information, so I'm deleting some unnecessary information which I don't want to talk about. I'm marking the adjusted R squared here. This is important. And now we can like interpret the regression output. Let me delete this kind of stuff. So that's our regression output. On one day where this guy is wild camping, he's spending about 25 euros. Because this guy also has to eat. These are the expenditures on one day where he was wild camping. And then since the t-stat is larger than 2, like this coefficient is significantly different from 0. You can also have a look at the confidence interval, like the 0 is not included in the confidence interval, and therefore we have to reject the null hypothesis. Let's have a look at the hypotheses once more. We are rejecting the null hypothesis that beta 0 is equal to 0. And we know that beta 0 is significantly different from 0. Then camping. On one day where this guy was camping, the daily bill was higher by about 11 euros. So on one day where the guy was using a camping site for the night, he was spending about, let's sum up this one plus that one, that's 36 euros and 70 cents. So like when we are interpreting this kind of coefficient, like we have to add it, and then we know the expenditures on a day where the guy was using the camping site. A hotel room is even more expensive than the camping site. So this is also in line with our intuition. On a day where the guy slept in a private apartment, it is the case that the coefficient is negative, but it's insignificant. So sleeping at a friend's place in a private home has like the same expenditure as if the guy would sleep like in form of the wild camping. Then the time trend is significantly negative. So here, like the t value in absolute terms is also larger than 2. So that's significant. So every day, the guy is able to save like 3 cents. So after like 10 days, he's able to save like 30 cents. And like after 100 days, he's always able like to save more. And over time, after 100 days, like after 3 months, he has learned so much that he can like cut down his expenditures by about 3 euros. So there is a small effect with respect to the time trend. The adjusted R squared takes a value of about 0.5. In a next step, I wanted to include like the GDP per capita variable. And in a first step, I downloaded the data set from a web page. I had to clean the data set several times because of the fact that here in this data set from the web page, there are 180 different countries included. And furthermore, it was a case that this data set was in English. but my labels were in German. So I had to modify the data set a little bit. Furthermore, I didn't have any information about the Kosovo, and therefore I assumed that GDP per capita in Kosovo is the same as in Montenegro. So, like, I had to make some adjustments here. But now I have to include this kind of information in our data set. I want to include this information here, GDP in nominal terms. The first country, that's Germany. So I want to have this amount of money here in this cell, 48,000. Then second country, that's Austria, Austria. So Österreich, which is here. So the number should be 52,000. And then we have Switzerland, and Switzerland is 91,000. So here the following command helps. VLOOKUP. So I'm looking up cell number E5. I'm looking up this name here, and I want to find the name in this area. So Q10 S32. Everything here is with dollar signs. So this area here is frozen. Important when I copy the information down, I always want to relate like to this variable here. And then I want to look up the third column. So I want to have the information here in this column. From column number S, like this is important. So I want to have like the third column, and I put the information in this cell. So let's check and include this information. Yeah, this is Germany. Second one is also Germany. Now it's Austria, Österreich, should be 51 or 52. And now it should be 91 for Switzerland. Let's check whether it works. Yes, it works. So I can copy all the information down. Once more, like this is the command VLOOKUP. I'm looking for Germany in this frozen area here, and I want to have the information from column number 3. Great. In the next step, I want to have the GDP in thousands of US dollar. So I have to divide this number by 1,000. 1,000, not 100. And then like I copy all the information down. So now I'm including like these variables as explanatory variables. Like these are the information with respect to where the guy was sleeping. And on top, I'm using like the Ballassa Samuelson variable here. So let's do that. Let's run the regression. Data analyzes regression. Okay. Input Y range. It's this area here, like from C4 to C622. And then like the information about the sibling place, the time trend, and GDP per capita. So G4 to K622, check at labels and an OK. I get this regression output, which also has to be formatted a little bit. Great. So I don't need these kind of information. It's deleted. And then always R squared. The adjusted R squared is important. So first of all, like the adjusted R squared is up, which is like nice. So like our additional variable, like GDP per capita, has some explanatory power. Let's check the significance. So like this is all significant here. Private is still insignificant. It's not larger than 2, the t-values. And like the other coefficients are significantly different from 0. So more or less, the results are in line with our previous regression. The time trend, the coefficient decreased to some extent. Like previously it was like minus 0.03, and now it is only minus 0.017. So we said previously every day this guy learns to save like 3 cents, and now it is only like 1.5 cents. So like this coefficient is 50% smaller than before. And maybe this is due to the fact that now we included like the GDP per capita variable, and yeah, like first he was visiting some countries which are very expensive, and only in the end he was visiting countries where the price level was lower. It is indeed the case that the coefficient is positive here. This implies that when he's visiting a country where GDP per capita is higher, also his expenditure is higher. So this is completely in line like with our hypothesis from the Ballassa-Samuelson theory. The last step, so here I prepared something because of the fact that we also want to run the regression in logs. So we have to take the natural log of expenditure and the natural log of GDP. So I prepared this already in this data set here. So one important point is what I have to show you. I have to sort the data a little bit. It was the case that some days the entry on the expenditure like was equal to 0. So on these days here, it was on the yellow days, it was the case that the expenditure was equal to 0. But you cannot take the natural log of a value equal to 0. Therefore, I said on these days, the expenditures are not 0, but 1. And then, of course, I'm able to take the natural log on these days. So, like one idea could also be like forget about these days, delete these days from our data set. Yeah, well, but like I didn't want to do that. Maybe we should do that. I don't know. Like what I'm realizing here is there are a lot of fours like in this data set, which implies that on these days he was sleeping at a private apartment. So maybe we should delete these numbers. But so like I reacted as follows. There were like a few days where the expenditures were equal to 0. You cannot take the natural log of 0. Therefore, I adjusted the data set and included a 1 here. So now we are able to run a regression. So I'm marking this area here. This is the data set which is important. So here we have the natural log of the expenditures, and here we have the natural log of GDP. When we run the regression, then like this is the regression output. I'll delete these numbers here. And augment it again. So view like 200%. So we have to interpret the numbers in the following way. For example, when the guy was sleeping in a hotel room, it is the case that the expenditures are 108% higher than when he's doing wild camping. A camping site is about 70% higher the expenditure than when he's wild camping. The time trend is not significant anymore. So here, time trend not significant anymore. And GDP per capita is significant. So when GDP per capita increases by 1%, the expenditure will increase by about 0.25%. Yeah, like I mentioned already that I have some doubts what to do, like with those days where the expenditures are equal to zero, like I included €1 instead of €0. But maybe this is not like appropriate because like suddenly like the private stays, they become significantly negative. This can be due to some effects. First of all, like what is the economic reason? Why should a private stay be less costly than wild camping? Yeah, because of the fact that maybe the friend not only supplies like a place to sleep, but also something to eat. So this influencer can save some money because he also gets a free meal. Like the negative sign definitely makes sense. But like I mentioned already, that there seems to be a correlation between the expenditures and the private overnight stays. And furthermore, like the private overnight stays, we only have a limited number of observations in our data set because we only have a few observations. So like in the previous regressions, this coefficient here was insignificant and now it becomes significant. I don't want to get deeper into this discussion of why and so on because we don't have too many observations for like this incidence here. What is important, I would say, is that we were able to like talk about the Ballassa-Samuelson theorem. This effect is significant like in all regressions and it has the right sign. So it's more costly in one country which has like a higher GDP per capita. This is already the end of my lecture. So please have a look whether you can replicate my results. Have a nice day. Bye-bye.